So we're multiplying rationals. When multiplying rationals, it's basically the same thing as simplifying, except you have two numerators and two denominators now. So yesterday what we did was we factored the tops, factored the numerators, factored the bottoms, factored the denominators, and then anything that was common to the top and the bottom after we stated restrictions, we could cancel off, correct? Same thing here, except we're going to have two numerators and two denominators. Make sure your phones are away. So, these are all monomials. Monomials means they're being multiplied together. There's no... Yeah. Anyways, there's no plus or minus signs. So the 4 is in its own brackets. The x squared is in its own brackets. Nope, didn't want that. Okay. The y squared is in its own brackets. The 3, the x, the y, the 8, the x. All in their own brackets. Then we state non-permissible values of our denominator. I'm not sure if you guys know this from teaching. So on your phones, it's probably not going to be helpful to you. All right. In the denominator, we have a 3. Can the 3 ever give me a restriction? No, it doesn't have a variable. Will the 8 give me a restriction? No. X, what can't x equal? 0. What's y can't equal? And this x can't equal? Do I have to state it twice, though? Now, once I've stated the restriction once, I'm good. So my NPVs are going to be x can't equal 0, y can't equal 0. If you wanted to, you could write it as x, y can't equal 0. Then just like yesterday, once we have NPVs stated, if we have something in the numerator that can cross off something in the denominator, we go ahead and do it. Now, x squared is like having what? X times x, correct? And y squared is like having y times y times y. That's a y squared, not a y cubed. I don't know why I did that. Y's. So we cross that off. So now I can cancel, it's always 1 for 1, right? So this y can cross off one of the y's. This x can cross off one of the x's. This x can cross off one of the x's. It's top or bottom, so numerator for denominator. You can't actually cross off like two denominators if they match, right? It has to be on the top and the bottom. So both my x's are gone on the top. Yeah, as long as it's numerator and denominator. As long as it's numerator and denominator. So I'm technically left with a 4 and a y on the top and a 3 times 8 on the bottom. But the 4 and the 8 can cancel just like they did yesterday. So as long as it's on the top somewhere in the numerator and it's on the bottom somewhere in the denominator, you can cancel. They don't have to be above each other. So 8 divided by 4 is 2. 4 divided by 4 is 1. So on the top, I'm left with, and when you cancel these off, these canceled off numbers are just ones. So I'm technically left with 1 times 1 times 1 times 1 times y. So I'm left with a y in the numerator. Over 3 times 1 times 1 times 2 times 1 times 1, which is 6. Less talking to help it. I have no idea what you're talking about. Eight divided by 4 is 2. 4 divided by 4 is 1. Y times 1 doesn't equal y squared. Y times 1 is just y. Eight divided by 4 is 2. 4 divided by 4 is 1. You can take a 4. What other 4? There is no other 4. I don't know what 4 you're talking about. The 4 came from the original question, but I don't know what other 4 you're talking about. Okay, on the top left for this next example, it says multiply. Write your answer in simplest form. Identify all non-permissible values. So this is the same as yesterday, but whole bunch of numerators and whole bunch of denominators. So I'm going to label them 1, 2, 3, 4. The reason why I'm labeling them is because I have to factor all 3 of them. I'm just going to factor them off to the side. And 4. Yeah. So number 1, x squared minus 6x minus 7. What multiplies to give me negative 7 and adds to give me negative 6. Like I said, if you can't factor, you're going to drown in this unit, as you can see, based on the 4 factors we have to do before we can even do the question. So it's just product sum because it's just a 1 in front. So we're going to get x minus 7, x plus 1. So I can go up here on this top left, and I have x minus 7, x plus 1. This expression equals this one. Number 2, x squared plus 5x plus 4. When I factor that one, it's what multiplies to give me 4 and adds to give me 5. What's it going to be? Multiplies to give me 4, adds to give me 5. 4 and 1. And we don't have to do decomp because there's a 1 in front of the x squared. Multiplication symbol, I'm going to do a dot because the multiplication symbol looks like an X to me. Yep. Number 3 is 2x squared plus 9x plus 4. I have to do decomp on this one because there's a number in front of the x squared. There's a coefficient. What multiplies to give me 4 and adds to give me 9? Multiplies to give me 8, adds to give me 9. I don't know why I said 4. Multiplies to give me 8, adds to give me 9. 1 and 8. We should equal sign. So this is equal to x. Take out an x, 2x plus 1. Take out a 4. We're left with 2x plus 1. So our factors are 2x plus 1 and x plus 4. Number 4 is decomp again. What multiplies to give me 42 and adds to give me negative 23. Negative 21 and negative 2, but, oh, it's a plus. Okay, yep, I agree. 3x squared minus 2x minus 21x plus 14. So in the first bracket, I can take out an x. The back bracket, I can take out a negative 7. So the next thing we have to do before we can cancel off anything common to the top and the bottom is state what? NPVs or restrictions. So there's going to be 4 of them because there's 4 factors in the denominator and they're all different. So my NPVs are going to be x plus 4 can't equal 0. X plus 1 can't equal 0. X minus 7 can't equal 0. 3x minus 2 can't equal 0. And then we have to solve them all. So x can't equal negative 4. X can't equal negative 1. X can't equal 7 when you add it over. And this can be 3x can't equal 2. X can't equal 2/3. You can never cancel until you state NPVs or you'll miss some of your NPVs, right? So we don't want to do that. So anything that matches exactly in the numerator with anything that matches exactly in the denominator, we can cancel. Does anything match? The x plus 1s do. What else does? X plus 4. It doesn't matter that this one's on the right and this one's on the left. What matters is that one of them is in the top in the numerator and one of them is in the bottom in the denominator. And then the x minus 7s. Well, if it was a 2x, you'd have 2 in its own brackets, x in its own brackets, because they wouldn't be attached by a plus or minus sign. 3x minus 2 is going nowhere, because there is no 3x minus 2 in the top. 2x plus 1 is going nowhere, because there's no 2x plus 1 in the bottom. Two x plus 1? Two x plus 1 over 3x minus 2. No. X plus 4 is attached. The only way it's going anywhere is if there's an x plus 4 on the top. Like x plus 4 is like u. And the only way I can cross u off is if there's an exact replica of u, not someone else with a head that doesn't look like you at all. Like you would say that if you could cross this x off and this x, you're saying that you cross each other's heads off with each other, and then your bodies are just dangling there dying. It's like real creepy and gross. So let's not do that. Let's not have some bleeding out people. Bleeding out people all over the place. Okay? You try this example. And then we're going to do division. Division is literally one extra step. Okay, on the top left, I can put the c squareds together, and this would be 8c squared plus 8cd, right? And you guys all told me to take an 8c out. And then you're left with c plus d. The 8c, because it's not attached to the plus or minus sign, is in its own brackets. And then an 8 goes on the bottom in its own brackets. Times. The top right side, I can take a 3 out. And I'm left with c minus a d. The bottom right is a difference of squares. So you're going to get a c minus d and a c plus d. Before I cancel off anything, I have to state non-permissible values. 8 doesn't give me a non-permissible value because 8 can never be 0. It's 8. These two can. So you do c minus d and PVs. non-permissible values. C minus D cannot equal 0. C plus D cannot equal 0. I'm just going to solve them for C. So I'm going to get C can't equal D, and C can't equal negative D. So technically, C can't equal plus or minus D. Now, because we saved our MPVs, our last step is to cancel. So the C minus D's can go. The C plus D's can go. So if it's overwhelming for you to do all the numbers at once, multiply across now and reduce after. 8 times C times 3 is 24C over 8. What can you reduce that to? Take an 8 out, get a 1. Take an 8 out, get a 3. So you're left with 3C. Yeah. No, C could equal 0 all it wants to. It's not going to. As long as it doesn't equal D, it's fine. If D was 0, then C technically couldn't be 0 because you get 0. Yeah. Okay. We're going to look at this one together quickly, and then we're going to do division. Division is honestly the same as multiplication, but a flip and an extra MPV. Yeah. So we have D over 2 pi r, and I'm going to write it out so you can see it, and I'm going to write it out in brackets because they're all multiplied except for this D minus 2. So D is in its own brackets over, it's equal to, 2 is in its own brackets, pi is in its own brackets, r is in its own brackets, times, what's up? 2 is in its own brackets, pi is in its own brackets, r is in its own brackets, h is in its own, that does not look like an r, all over D minus 2 in brackets because it's attached by a plus or minus sign. So anything that's just attached by multiplication signs, anything that's just attached by multiplication signs in its own brackets, anything that's attached by plus or minus signs goes in its own brackets. So when we go to state NPVs, we look at just our denominator. Can 2 ever be 0? No, it's 2. Can pi ever be 0? No, pi is like 3.141. It's a crazy decimal. So an irrational number. Then what about r? R can't equal 0. So that's going to be one of our NPVs. And then what about the D minus 2? Yeah. So D can't equal 2. Yeah, in a second. Okay. We look at the top and the bottom, the numerator and the denominator, see if there's anything we can cancel. The pi's can cancel. The r's can cancel. The 2's can cancel. Can this D cross off this D? No. This is a D in its own brackets. This is a D minus 2. It's a totally different thing. So in the top, we're left with DH over D minus 2. Yeah, because it's D times H, right? D can't equal 2. R can't equal 0. We're doing a division. It's the exact same. So the only difference between this one and the last one is there is a division sign. Now, we know that when we divide fractions, we invert and multiply what we're dividing by, which means we flip the second one and multiply. You never flip the first one. Some people are like, but it's nicer if I flip the first one. That's fine if it's nicer. That doesn't mean you can still do it. Okay, just because it looks prettier doesn't mean it's a good option. So we always flip the second half and multiply. The catch is there's also an extra NPV. So we're going to say NPV is for this bottom left and this bottom right. But what happens when I flip it? You have a new denominator. So you have to say NPVs for anything that is in the denominator or will be. So with division, you state NPVs of this one here. Oh, come on. This one here and this one here. The only one you don't state NPVs for is the top left because it never goes in the denominator. That's literally the only extra step. You flip it and state an extra NPV. Okay? So I'm going to none of these, I'm not going to label any of them and go off to the side and factor them because they're just product sum. If they were decomp, I for sure would. But these ones you can just do brackets with. So we're going to say what multiplies to give me -7 and adds to give me -6. -7 and 1. Yeah. So C -7 and C +1. And we can go right to brackets because there's a 1 in front of the C squared. What about the bottom left? What about the denominator? It's a difference of squares. So when you do the difference of squares of C squared minus 49, you're going to get C -7, C +7. Then I'm going to do multiplication. So in here, I'm going to do an extra step. I'm going to go like this. I flip and then do it. So I flip them now. So now on the top right, what can I do? Because I have a multiplication. You take out a C. The bottom right I can factor. What multiplies to give me 7 and adds to give me 8? 7 and 1. So C +7, bless you, C +1. So now I state my NPVs, and I state it for every single one except for the top left. Because this used to be in the denominator, and this is now in the denominator. So I have to state for both right ones. So I'm going to get C -7 can't equal 0. C +7 can't equal 0. C +7 can't equal 0 already did, so I'm not going to do it again. C +1 can't equal 0. C can't equal 0. And then C +7 can't equal 0, which I've already stated. This one right here. So I get C can't equal 7 when I solve that one. C can't equal -7 when I solve that one. C can't equal -1 when I solve that one. And this one's already solved. So it's not a lot different than multiplication, right? You just flip and state an extra NPV. That's it. Well, extra couple NPVs, but nonetheless. Then we can cancel. Yeah. Yes. So C +1 cancels. C +7 cancels. I can't do 2 for 1. It's not a deal. Okay? It's 1 for 1. So this C +7 cancels off that one, or I could have crossed this one off with that one, but I can't cross off both. Okay? C -7, C -7, so it equals C over C +7, where C can't equal 0, -1, plus or minus 7. Yeah. You can't cross off two denominators. It has to be a numerator for a denominator, always. Yeah. Can't do denominator for denominator. So if there was no c plus 7 at all in the top, then you'd have c plus 7 squared in the bottom. Like you can't take a denominator for a denominator. Your homework is it's on my sticky note, my really big sticky note.